I'm super excited to be here. This is one of those times where you're at a conference, and when you're meeting all these people for the first time that you've talked to for the last 3 to 4 years, it's just so fantastic. And all the new people that I've met, new faces, new companies, there's just so much going on in the confidential computing space that it just gets me super excited. So hopefully we can get through a session here. I know lots of organizations have been on stage talking about multi-party confidential computing, data clean rooms, that type of thing. I was trying to tap into a lot of those sessions so I wouldn't go and repeat things. So keep me honest here. If I'll try to whip through some of the things that might have been seen already. If you didn't catch all the sessions, I'll try to cover everything, at least in summary here. One of the things that really gets me excited about confidential computing is the type of people that I'm talking to nowadays. It's less about the security-focused people saying, hey, what is confidential computing? How does it work? More and more is getting from the decision makers, the BDEs, coming and saying, hey, all of the people that I work with is saying you got to get onto confidential computing, and you got to see how your applications can be run confidentially when running in the cloud. So more and more has been these, well, decision makers coming and saying, what's the value prop of confidential computing? So I end up showing this slide a lot more nowadays with some of these folks that I'm talking to. And it's generally, they'll get the gist from folks that are in their organization saying, yeah, I want to protect data in use. I get that. It's the full data life cycle. Now, what do I get out of this? Like, what are the things that I can do? What's the value prop that I can get from confidential computing? And these are some of the things that we'll bring up. This is where you can bring more workloads to the cloud, save money. Cloud first is the mantra that most companies already have. And here's where more workloads can come and move to the cloud, saving more money, doing more with the power of the cloud. And another theme that we'll talk in more depth here is all of what can you do to unlock more with your data. And this is where it's your own data, multi-party with multiple organizations, this new era of AI. We'll touch on those in this session here, as well as always keeping control of your data per confidential computing. Regulation and compliance, that's been a theme that's come up a lot today as well. That's probably about 50% of the engagements that I see from an Azure perspective. How do I move my workloads to the cloud, lift and shift, or net new, and meet regulatory compliance? Ultimately, as we all know, from a confidential computing point of view, you want to be able to verify. You trust, have that trust, but you must verify. And in that case, everyone gets to stay in control of their data by having that attestation of the cloud environment, of the full solution, so that you're in control of your data at all times. Let's focus in on that bucket around unlocking the power of data. This is where organizations are doing lots to bring more data to the cloud and want to bring more sensitive data to the cloud, even being able to process and get all these insights that were deemed impossible because it's either only my data set or I can't access broader data sets across the industry. And that's where confidential computing has really found one of these niche opportunities to say, well, now these bigger solutions can be put in place with companies at an industry scale collaborating together. And that's what we'll talk about here with building multi-party applications. Let's focus in on some of the challenges. So this is in the roles of people that get brought into some of these solutions and engagements, as well as some of the challenges that they might see. So you have people that come from a compliance perspective, legal, the regulatory compliance folks, security compliance folks. There's all these different worldwide regulations. Some have been brought up. I was in a session just an hour ago that talked about the diversity of all the regulations around the world, as well as any constraints that come up. Either I can't give my data into unauthorized hands, I can't have my data leave the boundaries of a country. So there's all these constraints that might come up. Things that happen today, like the question comes up, well, couldn't I do this without confidential computing? The reality that sets in is yes, but there's usually this lengthy legal process that comes into play that says, how does company A share company B their data, combine it together, process it? There's a big legal contract put in place, And in a lot of cases, I've gotten feedback that says that legal process just doesn't pan out, and then they just give up. Okay, the data owners, as you've seen in some of these examples, without confidential computing, there's a whole notion of de-identification. And sometimes it's error prone, sometimes it's just time intensive. So just time and money to be able to go and prep data for processing. And then you also lose the insights and lose the value of some of the data because it is lost as part of that anonymization process. And then inherently, when you only have your data set, you don't have as much data to get larger value and insights. And then the data scientists are working through the models, and they are even building models, and that IP is just as important. You've seen in some of the examples earlier today where it's not just the PII of the data, it's the IP within the models that needs to be protected. This is where confidential computing can come in and reinforce those legal agreements. It's not saying these data agreements, these legal agreements just completely go away, but here's technology that can help reinforce what's getting put into paper and actually expedite a lot of these legal processes to be able to have companies collaborate together. Now let's kick into some of the solutions and considerations when you're building, designing, trying to go do these multi-party data applications. These are some of the things that I've observed. This is based on engagements with our customers, partners. A lot of the solutions that you've seen potentially demoed here earlier today, these are some of the things that come up when building a solution for a customer. I'll just put in some of my notes and we'll get through these pretty quick because we've seen a lot of these examples and even demos earlier today. There's this notion of how real time does the processing need to happen. Here I frame it as batch analytics versus real-time analytics. This ends up being a place where it's like, hey, there's not necessarily one silver bullet solution that solves all data clean room or multi-party types needs for every case. In some cases, it gets divided into these buckets. Do I have a whole bunch of data that I'm doing a lot of detailed processing on in order to get insights and outcome as an output versus as like a batch job? In some cases, that can be just querying or AI. But ultimately, there's lots of time to be able to process, right? And that could be large data sets as well. Versus a scenario where, hey, I need to get the result instantly. This is like within milliseconds because the credit card got swiped. I need to detect if it's fraud. I'm running against a pre-trained data set or a pre-established data set to give me a quick answer. Well, these solutions can be very different and implemented and designed very differently to handle, and also like where you deploy. The latency requirements for some of these runtime checks can be very, very narrow. So having global distribution of the solution can be almost essential for these real-time transaction-based needs. Okay. Another aspect is well covered earlier today. I wish I could like copy paste some of the opaque slides and put them in here, but it's knowing who you're protecting from and what you're protecting. This comes down to the developer. Is it the code that you need to protect? Is it the model if it's an AI scenario? Are you protecting from the solution provider, the potential partner solution that provides the data clean room, the cloud provider, me in Azure in this case, or even the data provider protecting your IP from the data? In a zero trust construct there needs to be separation and data and model access constraint in all of these areas, from the infrastructure, the solution, the data, and it could be data from multiple sources, having security perimeters, privacy protection across each of these data sources. It can be one-to-many, many-to-one, many-to-many. It can be run as a consortium where there's a central body that runs in the tenant. From me in the cloud perspective, this is like, who runs the tenant, right? Is it the partner solution as a SaaS-based offering? Is it running in the customer tenant or like a bank? Is it their tenant and then the software is coming from another source, so equally protecting the software? All of these things come into play when designing the solution or having a customer give requirements to say, it needs to be in my tenant. Well, that is a case where then it can't run as a SaaS solution on an ISV. Whether there's privacy protection or not, sometimes these hard requirements come into play and need to be considered how they're going to deploy. Data properties can be very interesting in terms of how your solution could be altered in order to accommodate various needs that come from customers. Sometimes data can be coming from a different cloud tenant, a whole other cloud, or even on-prem, right? And understanding all these different sources and how you're going to bring those different data sets together. If they're too large of data sets, you could run into latency, right? And this is the size of the data set is going to limit where and how much data you can move if it needs to be processed with urgency in real time. So understanding the size of the data, where it's coming from, how it's all going to come together and be combined, and where that confidential computing environment needs to live. Data residency also comes into play. Many of the customers that we engage with are getting into compliance where the data can't actually leave the boundary of the country. This puts a lot of strain on us as a cloud infrastructure because we can't get our infrastructure deployed in enough data centers worldwide fast enough. So it's some interesting constraints that we see that equally need to be considered from a solution perspective as to where and how you operate, because so many more, especially these sovereign type customers, are looking to have solutions and data stay within certain regions and bounds. And one of the other things I want to bring up here is privacy and consent. We'll cover it with our, like the advertising example case. This is important that confidential computing doesn't get seen as a way to skirt around privacy regulation. It's important to understand for all of us that privacy regulation is put in place in a lot of cases to make sure that data use is with consent of the data owner, or sorry, of the individual in a lot of cases. Like my personal data won't be used for advertising unless I say yes. It's not like a technology that says, okay, now we're free to go do whatever we want with anyone's personal data without asking for consent. So there's still some pieces like that need to be considered so that individual consent can be built into the solutions as well. Code integrity and confidential ledgers. This is another interesting case where we've seen solutions and customers say, hey, we're actually collaborating on the code. It's not bringing the data together, it's actually bringing the code from different companies. And in this world where we have distributed ledger technology, you can actually have solutions be built with a network where multiple organizations are combining on the code, and there's consensus across that network of companies to bring integrity to that code. So everybody agrees on the code that's going to run through this networked consensus. And there's a tamper-proof audit log. That's that confidential computing backing on that ledger that says, hey, if anyone's going to add or do code changes, there's consensus to keep integrity on the code, as well as making sure it's a tamper-proof log from built in within confidential computing. And we have an open source framework there, as well as a managed service with our Azure Confidential Ledger. Other aspects, there's industry and regional specifics that come into play. Industries get interesting where there's certain expectations, constraints from an industry point of view. Like healthcare, many customers would come and say, is this solution HIPAA compliant in the US? Or in financial, is it PCI DSS compliant? So there's all these variations once you get into specific industry cases, and solutions can be optimized for different industries as well. It's almost like a choice from a solution perspective to be able to say, do I want to provide a general solution that tries to solve a more lower level general need across all these industries, or do I go hyper specific to one industry because I'm super familiar with the needs and regulations connectors of that industry? A couple other examples here is like healthcare with data formats and types of data that come in. When I was talking to some folks in Azure in the healthcare space, it's like, yeah, there's the FHIR standard, there's a DICOM standard, there's these different standards of data formats that need to be considered that a solution could be optimized for on top of the actual baseline of confidential computing and data clean rooms. So there's opportunities to go and extend these solutions to provide value add and more end-to-end optimizations for these different cases. And this will just help us all think about the full end-to-end of satisfying these customer needs. Another case in that regard is the data schema, right? In a lot of cases, I was just in the session with Opaque talking about their solution, and there was a really great conversation that popped up around, well, what happens when the data doesn't match? How do we know? And this come back with feedback from that I've seen from customers, especially in the healthcare space. Some of the cases were along the lines that says, different healthcare providers or data providers, you bring that together and there's no way to actually match that data, right? So this is an opportunity to be able to go and build more facilities into these multi-party data clean room applications to say, hey, you're blind to the data, so you can't understand the schema, but there's things that we can go and add in to say, okay, without being able to see the data, whether it's pre-trained on synthetic data, that was some of the things that I've seen come up equally in that last talk, as well as there's an opportunity to do matching of data with AI or other means built within the solution. Again, keep it built in a confidential way. Okay. I lost my notes here, so I'm going to look over here. Then we get into this case of AI. It's the new wave. I couldn't avoid talking about it just like everybody else, but it's that notion of I'm not just bringing multi-organizational data together and doing checks and queries on it. I'm actually trying to run more complex models, get these rich insights with all of this new power of AI. There's a few new cases that come up in terms of how do we think about confidential computing in these multi-party plus AI type applications. One of our researchers put a good page together that I'll try to summarize here, but that was the link there. So in this case, we mentioned before the intellectual property of the model and the model weights are equally important as protecting the data, as well understanding the data that goes into training to say, is this a public model with public training data, or is this a proprietary model even with public training data? Well, that's data that didn't need to be protected. But when you get into more industry-specific models, that's when they need to maybe have that private data. And then the training aspect of that model equally, like you've seen in some of the earlier sessions, is important to go and protect. And especially when it's cross-company data being used for training, it's obviously critical to be able to go and do that training within a confidential computing environment. It does stress the system. We'll talk about the scale that's needed. When you get into these more complex AI systems, you start to need GPUs. So I imagine that's going on in parallel with us with Phil from NVIDIA in another session. Federated learning is an interesting case that comes up. This is both in I'll give you two examples of federated learning. One is where, say, multiple banks would go and say, I'm okay in the cloud, but I can't have my data actually leave my tenant, right? So it's like I have my data, it's in confidential computing, that's all good, but I don't want my data to actually go into your tenant. I want it in my tenant. And it's like, okay, well, how can we go and bring the code to your tenant? Equally, it can go even more extreme to say, well, I actually don't even want to bring this data to the cloud. I'm totally constrained. I trust confidential computing, but I actually am constrained. I can't bring it to the cloud. Well, this is where you can bring confidential computing to the edge and then actually enable federated learning where you bring the model to the edge. And why you need confidential computing there is to make sure that model IP is protected because the on-prem person has their data and they're happy, right? So federated learning has been something that has come up. And the notion of federated learning is you bring the model to the data, you process on that data set, the model goes back and then aggregates in a central place. So you almost have all of these like mini models. If you've never seen federated learning, you have these, the mini models, I'll just say model prime in the picture here. And then those different models on the individual data sets go back to a central place in the cloud, get aggregated into the main model, and then you just iterate and send that model back down to all of the data sources. They could be in different tenants or another cloud or on-prem as needed, right? And that aggregation is what's able to go and build and train that model in a distributed fashion, a data distributed fashion. So I've seen all of these different types of solutions pop up. Again, just showcasing that it's not just, you know, multi-party data analytics or data clean rooms. Great, I have my solution, I can go forth. In a lot of cases, things need to be tailored to the specific needs of a customer, of constraints within the different environments where some of these are operating. And it just means that there's opportunity to go and extend our solutions to handle some of these different cases. Okay, inferencing is the main thing around, hey, I have my model, it's already been trained, it's all good. We know we need to protect the model and the weights because that's the IP in a lot of cases of the model owner. And now we get into that inference where you've seen some of the examples before, like that demo from Rashab during the keynote. If you were able to see it this morning, how do we make sure the requests or prompts into the system are protected? How do we make sure the responses back are all protected? Because this could be very private data. And policies can be created to enforce protection of any of those assets, whether it's on the model and a policy from the model provider, on the data as a policy from the data owner. This is where the attestation of all the different participants can be put into place. And I've actually been in a lot of conversations lately where the same questions come up even from a Microsoft point of view of like, how do we make sure our IP is protected if we want to go and run services in all these different places, even outside of Azure? So it's really good to see the right questions coming up, and now it's just a matter of going and seeing how we can go and build both the platform as well as the solution to solve some of these the needs within these constraints that are additionally coming up. I mentioned before, it's like the size does matter when it comes to the complexity and size of the models, as well as the complexity and size of the data. So this is where we start to put some constraints on what we can do with our compute infrastructure. So you can do inferencing as an example on small data sets and small models, or I had numbers here. Roughly, like a CPU can handle a model with about 100 million parameters. This is all subjective too. It depends on the workload, depends on the data set, but there gets to be some constraints that say, hey, there's only so much you can do with a CPU, and then you have to scale across CPUs. But even then, if you need to meet these low latency requirements to really operate fast with sub 100 millisecond response times, you're going to need to scale up. And as the models get more complex, as the data sets get bigger, we need to get into GPUs or a GPU, if not multiple GPUs and network GPUs. So this is on the roadmap of where things are headed, especially to do these more, 100 billion parameter models where everything is expected to be super fast, low latency, and with these super complex large language models, as well as the data sets can get bigger and bigger, sending queries and doing inference on much bigger data sets than just single prompts. So this is where we're gonna start to see the needs that really stress the infrastructure that we can provide. Today we have CPUs in Azure, where we have a preview with GPU, and then over time we have to see how we can scale and provide platform systems that can do cross GPU, and this is our partnership with NVIDIA, and these are the things that we're working through for what the future can hold. Okay, there's various solution paths. In Azure, we have a spectrum of offerings. This is where we've talked about our Intel SGX, these application enclaves that have been available that are super tight, all the way to our confidential VMs that have the full VM boundary. I'm super excited for everything in the middle with our confidential containers. We've seen a couple of solutions showcased today that run on our confidential containers and Azure container instances. This is fantastic as a serverless environment. So Microsoft actually does all the management, and they're fully attestable in their with a very tight isolation of just the container with a unique memory key for the container. And then we're building and working with our service partners, first party and third party, to go and have more services natively available in Azure that can be leveraged, like virtual desktop, Databricks, Data Explorer. So even our PaaS services can share the benefit of confidential computing behind in our infrastructure. Some built for purpose services as well, like that Azure Confidential Ledger. That's open source and built on a very specific confidential computing stack. We also love our ecosystem and the community that we're building here as a testament to this conference. We have new announcements from some of our close partners with Anjuna Opaque in for all within this last week, announced solutions and capabilities newly available on Azure to take advantage of some of our new infrastructure capabilities, as well as tackle some of these multi-party applications like you've seen demos here today. And in the last month or so, we've had several more. Just at Microsoft Build, I was able to announce a few more solutions. So it's really good and positive to see our partners really embracing the need to go and have these different solutions to tackle all of these multi-party, cross-company data clean room type scenarios. Industry examples, we've seen a few examples today. People talk about these. I'll just touch on a couple. The advertising space has seen this big uptick and need for clean rooms. I'll reiterate again, this is where, I would be so sad to see the cookies go away because they go around people's privacy, and all the whole cookies going away as advertising is going through this revamp. It still doesn't get rid of the need to consent for people's use of data for advertising. Confidential computing can come in and apply privacy protections as long as things are still consented by users. I would hate to see confidential computing be seen by regulators to say, oh, it's getting used to skirt around regulation, let's go and squash confidential computing. That would make me really sad because, as you know, we want this to be the future of computing. Financial, healthcare, these are all examples we've seen, as well as government organizations and bringing sovereignty. I talked about that data residency. That's what we see a lot in the sovereignty space. Let's talk about some real-life examples that we have in Azure, as well as stories that you can go read and see how the benefits of confidential computing in this multi-party data type of solutions can happen. Swift is trying to tackle global payments fraud. So if you don't know Swift, they're effectively a worldwide payments processor amongst something like 11,000 banks. So every time you make payments and money moves between banks, it's likely running on top of Swift. And they're working with Microsoft to go build a fraud anomaly detection platform on confidential computing. Beekeeper, this is super exciting. Beekeeper just announced their offering with Escrow AI into the Azure Marketplace in the last couple months. The case here is they partnered with Novartis to go and be able to detect rare diseases and run down, do their protective AI in Azure Confidential Computing to go from what could only be done in 10 years with disparate data sets and anonymization and trying to deduce. Took 10 years. Now they can do it in a matter of minutes within their privacy preserving solution that's built on top of Azure Confidential Computing. Another one here, a partner that's here this week is Decentric with their clean room solution. And they were able to unblock Goldbach for their data clean room advertising-based solution. So you can see how these different solutions are starting to pop up and have very specific industry use cases. So all these solutions can then optimize, again, in each of these industries and constraints. So with that, here's some links and resources, our Azure docs, other links to things. There's some samples that you can pull up from GitHub. Ultimately, there's freedom of choice. A customer could come and say, I only trust myself. I want to go and build my own solution here. Well, roll up your sleeves. Here's the infrastructure and some code. You can go. We have our ISVs. They build up all different levels of solutions as well. A full turnkey in the Azure Marketplace to make it as easy as possible to go and solve the different solution needs. So with that, I'm out of time, but I'm happy to stay for a few minutes if anyone has questions. I fully welcome a discussion here. If anyone has additive questions or points to bring up, I'm not a silo. This is the community of us all working together. Go ahead.
So, thank you, sir. So I'm just kind of curious, from your perspective, is it the case that you're seeing among clients that the legal and compliance teams are actually coming to the realization that confidential computing allows them to just sort of not provide a rubber stamp and approval and like this is a project that fully complies with everything, but at least allows projects to be fast-tracked?
Yeah, and I'd say it's a mix of both. In cases I've seen it happen very successfully. That beekeeper case is a great one, and I can even introduce you to a couple of those folks that are here. When I got into conversations with them, it was very much, hey, this was seen as a utility to be able to show from a FDA or legal perspective that this is possible, and so much of that legal red tape can be shortened into things that just took too long to go and implement because of that legal red tape are now being able to be shown, proven, verified with attestation, and then say, okay, this is good. There might still be legal contracts in place, but it definitely speeds up the acceptance to be able to go get the solution to life in order to get to that rubber stamp from a legal point of view. And each company is different. Some of the sovereign ones in the EU, they're a tough nut to crack in a lot of cases. And we get brought in directly with the lawyers to explain the technology, and that can be super hard because you're coming from someone that doesn't really care what the technology is or does, just has more legal perspective. I won't name names, but I actually learned of one of our customers that's going to do legal courses so that they know how to talk to their lawyers about what this technology can do from a regulatory perspective, but also meet them where their language and expectation is. And in some cases, it's very disparate, and we have to work to get it together, because the truth of the matter is it's not pervasive knowledge of what confidential computing is, especially from a regulatory and legal perspective.
Yeah, so thank you for the very nice presentation. I have actually two questions. So the first one is clearly confidential computing and data clean rooms going beyond just like trusted execution environments, but also like what's your view on that? Do you view the TEs as competitive to cryptographic computing, or you believe that there's complementary value there?
I feel like it's a loaded question, but
yes.
I definitely go there. So yeah, I see it as a very simple situation. That is, confidential computing is the lowest level of the stack. It's the platform. Yes. It is the hardware exactly. And the infrastructure that we run at this layer, right? In the long term, it's just computing. So every solution should just run on confidential computing, run on that computing with memory encryption and verifiability. And even in Azure, we see it as like, hey, that's the baseline. And we do features that you can crank up your assurance and verification just even from within an Azure feature perspective. I want to do guest attestation. Okay, that's there. I want to do disk encryption. Okay, that's there, right? So you can ratchet up. I want to use my own attestation. Okay, these are all options that you can take on within your specific solution. I see it the same with the cryptographic solutions, like MPC, homomorphic encryption. Any of these things are solution specific and additive on top of that base platform of computing and confidential computing. So if there's a case where, whether it's a regulation, all of the constraints that we brought up in this talk, any of those constraints could lead to, I need to do more on top of my baseline of confidential computing. I wouldn't start there. I wouldn't just wake up and say, oh, let's do all of these things so I can say I have the most different risk aversion techniques built into my solution. I would still recommend starting with confidential computing, and if there are questions that come up, then it's an additive as needed for the solution.
Okay, thank you. And the second question was actually about market education. How do you see the evolution of market education? What should we as tech vendors do to complement each other in that?
Yeah, and in terms of market education, do you mean like the different industries?
For example, the different industries, but also how do you educate the market about the value that confidential computing could bring
yeah.
to
So absolutely, this is lots of ideas, lots of things that Microsoft is trying to do in general. I think this is where there's things that the CCC can do and inject from a more neutral perspective so that there's not a bias as to a single vendor. That's one of the things I learned a lot at an IAPP conference. As soon as there's a business model behind it, there's a lot of maybe like dismissive bias to say like, hey, if you're here to protect privacy, I don't know if I can believe what you're saying because you have a business model that you're making money off of it. And this comes into a lot of different variations, right? Like if you're in advertising, no regulator likes talking to Meta. If you're in App Store stuff, no regulator likes to talk to Apple, right? So all of these cases, if there's a motivation around a business model, you have to be careful with how you go and explain, right? And this is where I think there could be, especially for confidential computing, avenues like where the CCC and us as a community of confidential computing can go and give the right message so that it's not biased to like a vendor. In my case, I'm Azure, and we do make money off of our compute infrastructure. So I just don't want that to be a bias in some of these conversations. I think I am out of time. I apologize. This is my hook getting pulled off stage. So thanks very much, everybody. I'll still hang around here if anyone wants to chat.
Thank you, Graham.